Hey everyone! Today we're diving into calculus for machine learning, focusing on derivatives and partial derivatives. If you've ever wondered how neural networks actually learn, this is the math that makes it happen. Calculus helps us find the best parameters for our models by showing us which direction to move in. Think of it as the GPS for model optimization. It tells us exactly how to adjust our weights to minimize error. Let's see how this actually works in the machine learning training loop. We start with a loss function that measures how wrong our model is. We calculate the derivative to get the gradient, which tells us the direction of steepest increase. We update our weights in the opposite direction to reduce the loss. Then we repeat this cycle over and over until we reach the minimum loss, and that's when our model is optimized. So what exactly is a derivative? It measures how fast a function is changing at any given point, basically the slope of the curve. Take the simple function f of x equals x squared. Its derivative is 2x, which means at any point x, the slope is 2 times x. For example, at x equals 3, the slope is 6, meaning the function is rising steeply. At x equals 0, the slope is 0, so that's a flat point at the bottom of the curve. Let me show you how to calculate derivatives in Python using the SOMPY library. We define x as a symbol, create our function x squared, and use spdiff to get the derivative, which gives us 2 times x. Now here's where it gets real for machine learning. Imagine a loss function L equals y minus w times x, all squared. When we take the derivative with respect to w, we see exactly how changing the weight w affects our loss. This is the gradient we use to update our model. In real machine learning, we don't just have one parameter, we have thousands. That's where partial derivatives come in. When you have a function with multiple variables like f of x and y, you calculate how it changes with respect to each variable separately. The partial derivative with respect to x treats y as a constant and gives us 2x. Same thing for y, we get 2y. In Python, it's the same diff function, just specify which variable. In neural networks, we calculate a partial derivative for every single weight, and together these form the gradient vector that guides our training. That's the power of calculus in machine learning.